All right. Welcome everybody to um, the assignment workshop for assignment one. My name is Manuel. I'm one of your TAs, and I'll be here answering questions as well. With the people who are here live as well. All right. Let's get started by reviewing the assignment. Um, I've gone ahead and I've taken the assignment instructions and I've simplified them a little bit just for the sake of time. This first part, oh, you guys probably need to be able to see my screen. All right, just to review the assignment, the first part is going to be creating some classes. So the first one is you're creating a class called desktop. It's going to have four properties, a double, two integers, a boolean, and a two-string method, and a four-argument constructor. The next one's pretty similar. You're going to make another class called laptop. It's going to have five properties this time. And it's also going to have a two-string, and it's going to have a five-argument constructor. You're going to make a fridge class with three properties, slightly different ones, two methods, again, a two-string and a three-argument constructor. And then you're going to have this electronic store class, which is going to be a little bit more involved. You're going to have this class. It's going to have a name, and then it's going to have three desktop objects, three laptop objects, and three fridge objects. So the objects we just mentioned above, you're going to have 9 of them instead of the electric store. And you have an option. So here, you can have one array or three variables to represent those three desktops. And it's the same thing for the laptop and the fridge. So you have to pick your poison. You're either going to deal with 3 arrays or 9 variables. Then you're going to have a one argument constructor, and the special part about this one is you're going to have to initialize all 9 objects we just talked about inside of that constructor. Then you're going to have a method called print stock, which is going to call print on all 9 objects. And keep in mind, you had to write two string methods for all of them already, so they should be printed out nicely. And then you're going to have another function called a search stock, which takes in a string, and it's going to compare the string that was given into it with all of the strings from the other objects that's inside, right? So this desktop, these desktops are going to have three two strings, and these laptops are going to have three two strings, and this fridge is going to have three two strings, right? And so you're going to have to use the contains method to compare the string that was given to you to the strings that you can generate from these objects. So you're probably going to have to use something like contains to compare strings. You may have to also use something like toUpperCase as well in order to get rid of the case sensitivity. Yeah, that's electronic store, and we'll come back to this one with a little bit more detail in a bit. Here we have the tester class. The tester class has no properties. It just has a main method. So all of the code for this tester class is going to be in the main method. And the algorithm for the main method is described up here, but I just have it in a more of a pseudocode sort of way of written it. So that's a little bit easier to understand. So here the first thing you're supposed to do is instantiate an electronic store object. Then you have to call print stock on that store object that you just made. And then repeatedly, which tells you it's probably going to be some sort of loop, you're going to first prompt the user to enter the name of an item to search for. And you're going to use the scanner object to read the keyboard input. So maybe, for example, in here, this example that they have here, they are searching for the term desk, right? So they type in the word desk, and That's this first part, is where you just grab that from the keyboard. Then you check if the user has typed in quit, and you can check if quit was typed by using the equals method. So we can compare strings using the equals method. If they typed in quit, then the program should end. Otherwise, if they did not type in quit, they should call search stock with the string that they just gave us. Like, for example, here would be desk. So you call search stock with the word desk on the electric store object you just made. And search stock is going to return a Boolean, true or false, depending on whether the item was found in the store. If it was found, you print this. If it was not found, you print that. All right. And the professor has a little demo here as well. All right. So those are the instructions. I trust that you've already read them. So that's why I went through them quickly. But now let's try to break them down a little bit more. So here I've taken these small snippets I wrote for you guys, and I put it in one document here. And I organized them by the knowledge that you're going to have in order to complete them. So if we start for the first one, actually you can see from the first three parts of this assignment, they're very similar, and they all require the same amount of knowledge. So if you can do one of them, you could probably do all three. What you're going to do basically is create a class and make properties. So that's, if you know how to create a class and add variables to it, that's just that part. Do the toString for all three of these. You're going to have to know how to do toString methods, which I'll show you. And then you're going to have to make constructors for all of them. Now, there are different number of arguments for all of them, but yeah, just you're going to have to make constructors for them. The next part for the electronic store. So again, we start off with having to know having to know how to make a class, and having to know how to add properties, just as before. But now there's a few more elements. For example, you're allowed to use an array if you want. So in order to do the arrays and not to do the variables, you're going to have to know how to declare, initialize, and manipulate arrays. We'll take a look at that as well. Then again, constructors, something you're going to have to make. But this time, you're not just creating a constructor, you're also calling your constructors. So in the last three previous classes, we were just making the constructors. But for this next class, we're actually going to be calling all three constructors that we made previously from within our constructor. From within our electronic store constructor, we'll be calling the other three constructors, making 9 calls in total for the 9 objects that are in this electronic store. So we'll take a look at initializing objects. You're going to have to know how to make methods. So the methods you have to make here are called print stock and search stock. So we'll take a look at making methods and returning values from methods. One of these methods, print stock, requires you to call the print function on every object in your electronic store. So you're going to have to call print on all 3 desktops, all 3 laptops, all 3 fridges. And if the desktop, laptop, and fridge classes have the toString method defined correctly, then when you call print, it should all look nice. So we'll take a look at toStrings as well. And then for your search stock function, you're going to need a few skills to be able to do this one. So firstly, you're gonna need to know how to use the toUppercase. You're probably gonna have to know how to use contains, and you're probably gonna have to understand how to use the toString methods, because there's a few things you have to do to solve this question, right? First, you have to grab all of your objects, your desktop, your laptops, your fridges, right? And you have to grab their string, right? Because you're gonna have because you're gonna need to know whether the string that was coming into this function, if that string is contained inside of these other strings, right? So you're gonna have to call toString on all of these functions, on all of these objects. I mean, call toString to get their strings, and then you're gonna have to probably uppercase them so you get rid of sensitivity, and then check if the incoming string is contained in any of these objects. We'll take a look at how to do these things individually. We'll take a look at how to use the contains. We'll take a look at how to use the to uppercase. We'll take a look at toString, and hopefully you'll be able to put the pieces together. Then the last class is the tester. Now we notice that there's no properties. There's no other methods other than the main method either. So in this part, we're going to start by initializing a store object, and that's just going to be whether or not you can call constructors properly. Then the next part is going to be calling print stock. That's just about whether or not you know how to call a method on an object. That's just literally just calling print stock on the electric store you just made. Then the next part says repeatedly in the instructions. Repeatedly probably means a loop, right? So you're going to have to know how to make a loop for this part. Then in the loop, you're going to have to prompt the user to enter the name of an item. That's going to require you to use a scanner object and know how to get the keyboard input. And next, you're going to have to grab the input and check if it was equal to quit. You're going to have to use the equals method for that. So you're going to have to know how the equals method works. Next, if it's not equal to quit, then you're going to call search stock. Right? So in order to be able to call search stock, you need to know how to call methods on objects. And then you need to also know how to use the return value for that method. Right? So in this case, you're going to get a return value of a Boolean, and you're going to decide what to print based on that Boolean, right? So you need to know not only how to call it, but how to get the return back and how to use that return statement or return value. So here, just looking at the legend again, I've gone ahead and taken all of these things. These are all the things you need to know for the assignment, right? And I've gone and I've found where they are in the textbook, so we can do a little example for each one. All right. Before we get started, are there any questions? All right, looks like we're all good. So let's get started with creating a class. So here we found it, I think it was on page 24. And these page numbers are the real pages, by the way. So like not the PDF pages, like the numbers down here. So here at page 24, we find how to make objects, and we'll do a quick little example here. Here they have an address, so we'll just do the same example. So in IntelliJ, we can come over here, create a new class. Let's call it address. And so there you go. That's the class. So that's literally it. We've made the class. It's called address. Now the next part would be like creating like variables, right, or properties. So here we have an example of a double, an int, a boolean, an int, an int. So I'll use stuff like that. So I don't know. We could have something like int street number. We can have boolean is or has mailbox or something like that, right? We can use string, street number, street name, right, etc. You can use a double, um, let's say, area, like ground area size, maybe something like that. So that's it. That's how you make a class, and that's how you define its properties. The next part we'll take a look at is declaring, initializing, and manipulating arrays. So let's just do that. Here on your class notes on page 10, we have some examples of how to use an array. So here's how you would do it in Python. Here's how you would do it in Java. Let's make an example. So if I make, have this tester thing here, which just says hello world here. If we have, we can make an array here, for example. So if we wanted to make an array, to hold the number of days, we could have something like int. We use a square bracket to denote that it's an array, and then we could call it days. And then now we have two options. We could just not declare it like that, but then if we try to use it later, it's going to get mad at us. So right there you can see we have an error because we haven't initialized it. So we're going to say equals, and then we're going to use the new keyword. Okay, we always use the new keyword when making new arrays, when like actually putting an array into RAM. Then we say the name of the variable, the data type, which is a array of integers, and then you can put the size. Right. So that's us making an array, and we can put stuff in the array with the square bracket operator. So here I'm going to set the first element of the array to, like, I don't know, 5, and then I can that doesn't print nicely. Maybe I'll just print what's in there in the array. You notice it doesn't print nicely, unlike in Python. I think that would actually print nicely. All right. So yeah, that's how you make arrays, and you can make arrays of any type. So I can make an array of addresses, for example, like this, and it's the same idea, right? If I try to print this out, I'd also get an error because I haven't actually initialized the array. I've only declared it. So again, use the new keyword to put an array into memory and put the name of the data type, which is in this case an array of addresses, and then put the size in there as well. Same idea, but now we want to put an address in there. Before we just put in the value 5 up here, but now we actually need to make an address object inside of the array. So we use the new keyword again to put an address onto RAM. All right. We can also change the value of these properties that's in the array. So we can do something like addresses at position 0. That's going to give us back this address that we just made, and from there we can change the I don't know, the street number, for example, or the street name is now equal to Colonel by Drive or whatever, and there you go. So that's manipulating arrays and initializing them, declaring them and stuff. Next part we're going to take a look at is the toString. So right now, if we actually execute this example, we'll see that this won't print out nicely. Like, it prints out like this. That's not very nice. That doesn't really look like an address that's recognizable. So we can create something called a toString method. Now this method will be called automatically whenever we try to represent our object as a string. In this case, Java actually creates a toString method for us by default. So the reason we can see this is because by default Java actually has a toString method for all of your objects, but by default it looks like this. Like it doesn't look very informative, let's say. So what we're going to do is we're going to write our own toString method so that whenever we have a situation like this where we're trying to print an object that is an address object, it won't use this old toString method anymore. It'll use the one we just made. So to do that, we make a method, public string toString, and this just needs to return something, a string. Now we can whatever string we return here will be the string that is displayed when we try to print it. Now we could, for example's sake, just hard code a value here. So this is what an address is supposed to look like. And now we can see that when we run this, we no longer get that ugly address thing. We get this, right? Because now what Java always does is whenever you try to display a string using this print method, it always calls the toString method, right? And we just defined ours, right? Now we're not getting that default ugly one. We can change this, and it would be really nice if we had some of these properties being printed out here, right? So, for example, we could print our street name, right? And now when we run this, see, we get a little bit more information. Now this is not like completely 100% complete. Probably what we would want to do is do something like this, right? Maybe even put a little space in there, right? And you can go ahead and give it a street number. You know, I don't know what the actual number is. I'm guessing. So we can run that, and now we get a much nicer looking string. And we can go ahead and add all of these properties in there as well. But that's the basic idea of a toString method. That's how we create them anyway. And here we can see we're actually implicitly calling toString method. Because like I said, whenever we try to display an object, it's just going to call the toString method. But we could just call the toString method ourselves. You know, I mean, I wouldn't recommend doing it in the way I'm going to show you now because it's kind of confusing. But you could, for example, just call toString like this, right? And this would give us the exact same output, right? Because this is essentially what the compiler is going to do behind your back. It's just going to call the toString for you, right? We can actually, though, abuse this to do more stuff. So, for example, we could create a brand new variable called current address, for example, and we can make this equal to the result of our toString call, for example. Right? Now, this can be very helpful when you want to do some sort of information with the toString method, with the toString information here. Like, yes, we could go into this address object ourselves and just try to like recreate the toString method, but you know, maybe there's some special stuff that's put in that toString method that doesn't exist anywhere else. Like they could say something like, your address is something like this. And now you wouldn't be able to recreate this toString method as easily because there's information in here that doesn't exist anywhere else in the object, right? The string here, your address is, right? So sometimes it's useful to actually explicitly call the toString method yourself so you can extract information that's like just in the toString output. And this is going to be useful for your assignment because you're going to be searching this string, this toString result, right? So let me just keep going with this example. So, we can print this out normally, and we'll see that it gets printed twice, exactly the same. But we can modify this string, right? For example, we can say, and this other person also lives here. And then, and this other person, I don't know, Jimmy also lives here, right? Something like this. And now we've gone ahead and we've modified the original string, right? So we can call the toString method to extract the result of calling toString and then modify it ourselves, okay? And you'll probably have to do that in the assignment, or maybe you'll do it in a slightly different way, but this might be useful to know. All right, so let's move on. It's toString methods. So creating constructors and or calling them. So, and by the way, I didn't go to the page, but it was on page 71, the toString information. So if you want to find out more, there's a whole thing here on the textbook. All right, next part, let's talk about constructors. So you can find out about constructors here. So what is a constructor? Let's talk about it for a second. So notice here, I'll just clean this up a little bit. So notice in this example that we are having to define what the address looks like in multiple lines of code, right? And we only have 2 lines of code here because it's a really short example. But even if we had actually gone through and finished this one example, we would have noticed that it would have taken 4 lines of code, right? Because we've got like 4 properties here. So we would have had to keep going, do dot ground area size equals and dot has mailbox equals and so on and so forth. So that's very repetitive type of coding, and we can do something a little better. So we can make a constructor. A constructor is a function or a method that is automatically called for free when that object is made. Okay. So let me give an example of this. Okay. I'm going to make a pretty useless constructor here as an example of what I mean. Here, to make a constructor, we write the word public, then the name of the class, open close brackets, and open close curly brackets. Okay. So this will be automatically called for free whenever an address is made. And to prove that to you, I'm going to put a print in here. Just saying, I am now alive, right? We can notice here that every time we use the new keyword on address, this will be called. Right? So that's what a constructor is. When we use the new keyword on address, this constructor is called. All right? So we should expect it to be, well, let's run it. All right, so here we noticed it only printed once, right? Because we called the new keyword twice, yes, but we only called it once on the address. We called it on the address array, But keep in mind, right? An array is not the same data type as like the thing that the array is holding, right? So an array of addresses is not the same data type as an address, right? This does not proc the constructor being called, but this does. Okay. All right. So here we can see I am now live. So you can see that the code is being called automatically when we construct it. Now this is useful because we can set default values, for example. So if we wanted this to be the default value for any address that's ever made, then we could do that. We could come over here and we could set, and let's say instead of I am alive, let's say I am an address being created, and we could set default values. So for example, we could set the street number equal to this, and the street name equal to right, something like this. And now we can get rid of these two lines, and we'll see that we get the same output, right? And that's because this code was called automatically for free, right? When this address was made, right? When this new keyword was invoked, and so we got to set the variables for free. Now there's other types of constructors we can make, right? So we can make a constructor that has arguments, for example. So if we face the exact same thing, but this time we pass in some arguments like int sn and int s or string s name. All right. Now instead of setting these values to just a default value, I can set them equal to the numbers that are being passed in as an argument to this function. Right. So here I'll set the street number equal to sn snum and the street name equal to sname. And we can still see that everything works as before, but now we have a new option. We can come over here and create a new address, and this time we can pass in some values. So we can do something like 725 or 725 to 6 or something. Parliament Drive or something. And then we can go ahead and print that. And there we go. Okay. So, and we can see, by the way, look, an address being created is called twice, right? Because this whole function is called, right, for free, right, every time. All right, cool. Anyways, so that's those are constructors. All right. Cool. So let's move on. Uh, Next part is going to be about defining methods with arguments and using return statements where appropriate and being able to call a method. Okay, so let's do a little method for the address. So we want to do an address with an argument, and we can see it as well on the course notes. There's a lot of examples here. Here we have like a car where they're making a few methods. One is called draw, one's called move, and here we can see the professor calling them from from a static point of view and from a non-static point of view. For this assignment, you don't have to worry about the difference. I don't think any of your functions should be static other than your main function. So the difference won't matter too much here, but you can see an example anyway. I'll do an example. So I'll steal the car example. So here we can make a class called car, for example. We can give it some stats like the speed and a location. Then we can go ahead, we'll make a car tester. All right, so we can, and probably we want to make a nice little constructor here. Okay, so yeah, we have some cars there, and maybe we have a method called move, right? Public, and we'll make this void. I don't think it needs to return anything. Move, and it's going to take a, let's say, direction. So in this example, well, they actually take another car, which is interesting. Let's do an example where we just move the x position. So new new x. All right, so we can. This is how you make a method. Notice I didn't use the word static like we usually use for our main methods. This is because all methods, actually that's not true. Not all methods have to be static, but all the ones in this assignment I think have to be. The difference between static and non-static just means that you need an actual object, like you need an actual car to call move. You can't just call it by itself. So let's do an example here. Actually, let's do something like as well, like the year. So int year. We can have a function here called is older than that returns a boolean and takes in another car. So I think this would be a good example. So we want to return true if another car is younger, or let's say newer, than this car, right? So we want it to be if we have, if we had example, if we had a car 1 that was a 2,000-year-old car, or from the year 2000, and we had car 2 that was from the year 2005, we would know that car 1 is older. So we would like to say mathematically that car 1 is older than car 2, right? Or we would want to say that car 1 dot is older than car 2, right? These would be about as equivalent, right? All right, so to do this, right, we can use this keyword to compare our year and compare it to the other car's year, right? And then we can just return the result from that, right? So this would be like a really simple method. Probably here we probably want to pass in the year, set the year. So to finish this example off, we would have something like, car 1 equals new car, and then 0, 0, 2000. Zeros, I think I'm missing a number. 0. There we go. And then for car 2, we could have the same thing, but be 2005, right? And now we could print which car is older. So is car 1 older than car2, and then we could add here car1 dot is older than car2. And I'll zoom out a little bit for this. Okay. Oh, by the way, I think I actually have a tiny little typo here because greater than would actually be considered a smaller year, right? Yeah, because years are, the smaller a number year, the older it is, right? So you'd have to do the flip the sign like this. And let's actually run this one. All right, there you go. All right, so that's an example of a method, okay? And one thing I want to notice or to mention to you is that this isn't the only way of doing it. Or I mean, this isn't the only way of using the return value from this method call. One thing we could do, for example, is save it as a variable. So Boolean is older equals car1 dot is older than car2, right? And then you might be able to use this if statement to print out two different things. So you could say if is older, right? So if our car is older, then we can say system.out.println car1 is older than car2. Otherwise, we'll print out the opposite, right? And I just want to mention this to you because some people get a little confused as to like how to do this part. There's something similar on the assignment. So I would say make sure that you remember that when you call a method, if this method has a return statement, like this one does, you can save the result of that return statement to another variable and then manipulate that variable. Kind of like what we did with the toString method, right? All right, so moving on. The next part, and if you guys have any questions at any point, just let me know. Um, so I couldn't find an example of the contains method in the textbook, but we'll just do a little example. So, here if I wanted to know if the address the number 1020. So if I go back to this example, okay, we see that 1025 here is printed alongside the rest of the address, right? So what if we just wanted to check if the address is 1025, right? We could do something like this, right? Or here's a slightly better example. What if we wanted to check if the address was on the same street as us, right? Here we have Colonel. Here we have Parliament. We wanted to check if it was Colonel, right? Without having like we get the entire string, right? How do you check that just a small part of the string is equal to what you want it to be, right? Or contains it? We can use the contains method, right? So we can say, for example, we can do something like grab the first address and here, let me make it. Yeah, we'll do the address. So we'll grab the address, grab the toString, then we can call contains, right? So we can say, does it contain the string, colonel, for example, right? And here we see it true, right? And if we ran it on the next address, right, we have a false, right? But if we change this to, because colonel's not in this string, right? But if we change this to Parliament, right? Would get true again, right? So yeah, that's using the contains method to find if a string is inside of another string, right? Cool. So let's move on. The next part is how to use dot to uppercase. I think you guys had something similar in uh, in Python. So here I'm gonna just say to upper string. To give you an example, or to uppercase, I mean. So here what we're doing is we're just taking this string and we're just putting them all capitals, right? So the way you do it is you grab your string, right? So I'll give you another example. So string, my string, and I can call it something like hello world, right? You grab your string, wherever it is, and you just call dot to uppercase at the end. Right? Now the reason I did to string first before I called to uppercase was so that I could grab the result of the toString method, right? It doesn't even like when you do this, right? Like this is just an error. Like this doesn't even make sense, right? Because here you're saying grab the object and turn it to an uppercase, but it doesn't make sense, right? Like you gotta grab a string and turn that into an uppercase, right? The only way of grabbing the string representation of an object is to call toString first. Right? So keep that in mind. This is important for the assignment. All right. Moving on, so you're gonna have to know how to make looping control structures. I pretty much think you'll be able to do that, like no problem. I guess I'll do a quick example because we have time. Um, all right, so let's do an example of like a while loop. Do like while true, system.out.println hello world. All right, and let's do something slightly more interesting. So we can do something like, let me make an integer called x, make it 0, and every time we print x, and then we increment x, and then if x ever hits 10, we break out. So there you go. So that's like a loop. And then you're gonna have to know how to read in keyboard input using the scanner object. So that's to find that. Oh, and for loops, you can just go here and take a look at some of these looping examples. Okay, so to do the scanner, let's head over to page 11. All right, so this you're gonna have to either memorize or copy paste it somewhere. I memorizing is probably better. So this gives us access to the scanner object that we're going to use to read the keyboard input. And then this is how you actually create the object. All right. And I would say like, this one here. Try to either, again, memorize this or try to write it down somewhere. So here, yeah, just trying to memorize this or try to write this down. You could try to figure out what this means. It's not super complicated. You're making a scanner object called keyboard using the new keyword that we looked at before, and the argument to the scanner constructor is another object. In this case, it's called system.in. If you're ever curious about these things, you can always right click on it and go to the implementation and you know, look at the code and try to figure it out. Anyways, so that's that. Just try to memorize that. To use the keyboard, let's grab something from the user. So user input. Okay, it's good. We're gonna grab a string for now. I'm gonna do keyboard dot. So we have a lot of options here. The one you're probably gonna use the most is next line. Okay, that's gonna give you. That's going to, as soon as this is called, your Java is going to hang. Means it's not going to continue. It's not going to go to the next line of code. It's going to hang and wait and listen to the keyboard. When it listens to it and it hears that you've pressed enter, all of the keys that you had pressed and released before you pressed enter, but after this was called, will be returned back to you in a single string. So I'll just print it out. You typed and then the user input. So in this example, I can run this and I could say hello world, and here it says you typed hello world, right? You can do this for different types of data types. So if you wanted to grab an integer, you could do the same thing, but instead of saying next line, say next int. All right. So same thing here again. I'll type in hello world. Now I type in 5. Type in 5. You do this for all the data types, I think, pretty much. Like you can do it for doubles. I guess I'll just show you. Right, do it for doubles. And so on. All right. So that's that. I think in the assignment you only need to use the next line anyway. So now I want to combine these two ideas. Notice that like you can do something kind of clever here. So if you grab this and we stick it in here, for example. All right. Give this a run. You'll notice we get spam now, basically. I can say hello. What happened here? It's kind of. Okay, so type here a little bit. Sorry, I seem to have some bug here. This is why I shouldn't just keep creeping on my code. It's just delete it when I'm done with it. But all right. Yeah, so here we have, a little system here where you can keep asking us to enter stuff. Now, keep in mind, you can also react to what this person's typing, right? So for example, instead of saying if x equals 10 break, right, we can make this maybe more interesting now. So we can say, for example, if the user input contains, purple, then we say you found the secret code, for example, right? So here we have it asking us hello, hi, hi, hello, hi, and then we type in purple, and it says you found the secret code. And we can even make this more interesting by breaking out and saying something to congratulate them at the end if they broke out. Congrats, you win. Right? So we run this again. So now it's almost like a password game. Hi, hello, hi, no, whatever. Can't get out of it, right? No matter how many times I do it, right? Right? And then the moment I type in purple or whatever, purple something, it says you typed purple, you found the secret code, and you win. All right, cool. So that's how to use the scanner. And the last one is how to use the equals method. So let me give you an example. All right, so let's say I have a string. Say string 1, and it's like hello, and this is another string, string 2, and I'm gonna say it hello. Now, this demonstration here could blow up in my face because well, let's see. So if I say something like string 1 equals string 2, say, and then if they are the same, we say they are the same, right? And if we say they are not the same, right? What would we expect it to print, right? We'd always expect it to print this, right? Right. Now, the reason I said that this presentation might blow up in my face is because here we actually see that it does actually print they are the same, which is the intuitive answer that you would think. Now, the problem is, okay, this isn't always true. Okay, so when I run this, I wonder if I'll actually be able to get it to go, but probably not because life hates me. Um, just because you're using these two strings are actually the same. When you use equal equals like this, you're not guaranteed to have they are the same printed every time. Um, that is, it has to do with how strings are stored in memory, right? Remember, a string is not a primitive data type. A string is an object, right? Like you can right click on it and go look at the string object definition. You see, it has a bunch of private variables and properties and methods and stuff. It's an object. It's not a data type like an integer, right? So you can't compare objects like this, okay? The problem doing that is that it doesn't always give you the result you want, right? Now, the reason why I think this is actually working is because I think the way that Java works, this is just as a guess. I'm pretty sure that the way Java works is when you have a string that's typed out like this, pretty sure that this is like a string literal or whatever, and this is stored in a specific place in memory. Um, like because this word hello like is from the actual .java file that I hard coded myself. This is in a different place in memory than like a string that would be created if I was building it up, right? And so because of that, these two hellos are probably being stored in the same place in memory, which is why we're getting this equals being correct. I think if we had something more like this, it'd be less likely to give us the same result. But you know, it might just oh yeah, there you go. So now it says they're not the same, right? So you see, all we did here was change how this string was constructed, right? And it went from saying they're the same to saying they're not the same, even though in both cases string 1 and string 2 are equal to hello, right? This is the problem, right? And I'll show you that again. So if I put that back to how it was, it says they're the same. If I, instead of doing it like this, I build the string like that, exactly the same string, it says they're not the same, right? That's because this equals isn't strong enough for what we want. What we want to do is use a dot equals, right? So instead of saying equals, we'll say dot equals, like that. And now it actually works. All right. So that's how you compare strings in Java. So in Java. All right. Don't use the equals. As you can see right there, you can just have a world of trouble, world of hate, if you rely on that. All right, and I think that was the last part. So using that, you should know that should be everything you need to know for the assignment. I'm going to post all of this and this code as well in the assignment workshop channel and pin it as well. Are there any other questions? All right, I'll stick around for a little bit, and you guys have any more, you can ask me. Any questions, you can ask me. I'll end the recording here.